Hi students, now I am explaining you GOC based organic chemistry based questions, 10 questions within 10 minutes. Look at the question number 26. Which of the following compound has zero dipole moment in one of the stable conformation? Look at the option, fourth option, meso compound is given, meso compound. The compound is given CH3, HCl, HCl, CH3. This meso compound expressed in Newman projection stable form. The stable Newman projection is, this is considered as front carbon, this is considered as back carbon. So at front carbon represented with dot, at front carbon 3 bonds represent like this. This is the Newman representation. CH3, HCl. Each bond between the two bonds, the bond angle is 120 degrees. This is back carbon represented with circle. Here the CH3 is present, here chlorine is present, here H is present. Between them bond angle separation 180, between them bond angle separation 180, between them bond angle separation is 180. This is the stable form of this meso compound, stable form. So here dipole moment value, what is that? 0. So the question is, what is the question they asked? Which of the following compound has zero dipole moment in one of the stable conformation? This conformation is the staggered conformation, anti-conformation. So in this conformation, this molecule is stable. Look at the next question, 27th question. Which of the following substituent in an electron donating group overall? So here these groups are present on the benzene ring. Which group act as a electron donating group? Electron donating group means which groups gives the electron density to benzene ring. That is electron donating group. So bromine having the lone pair of electrons, it is donate the electron density, that is plus M effect. But nitrogen doesn't donate the electron density. Lone pair of electron is not available. It is having the positive charge. Oxygen having the lone pair of electrons, it is also donate the electron density. But here the carbon is connected to the 3 chlorine atoms. Compared to carbon, chlorine is the more electronegative element, electrons moving towards the chlorine side. So it is not act as a donating group, it is act as a withdrawing group. This is minus M effect and as well as minus I effect. So between the comparison, which is electron donating group? So here OCH3 act as a only plus M effect. But here bromine act as a plus M as well as minus I effect because of electronegativity. Here oxygen has 2p orbital, carbon has 2p orbital, here 2p orbital, here 2p orbital. Size is same, overlapping is possible, plus M effect is dominating compared to minus I effect. But here the minus I effect is dominating in the case of halogens. So option is this one, third option. Next question number 28. What is the question 28? Inductive effect of chlorine is minimum on. You know that already inductive effect is distance dependent. To the carbon chain, different electronegative atom or group of atoms are connected at any end. Due to more electronegative in nature, the electron density, due to more electronegative in nature, the electron density is decreases here. Here the electron density more decreases because of this carbon is nearer to this atom. So electron density is less decreases, electron density very less decreases. Here the inductive effect is almost negligible because of distance is more. Inductive effect almost applicable to up to third carbon atom. It is minimum at fourth carbon. Next question, observe that. In which of the following compound CH3 shows minus I effect? Minus I effect means withdraw electrons towards itself. So here in the first molecule, this carbon is sp2 hybridized carbon, this carbon is sp3 hybridized carbon. sp2 hybridized carbon, you know that already more electronegative element, because of percentage of S character increases, electronegativity of the atom increases. So this CH3 act as a plus I group, giving in electrons to the more electronegative carbon. Here also same, this CH3 act as a plus I group because of benzene carbon is more electronegative element. So electron density moving towards the benzene ring side, it is act as a plus I group. Here also it is act as a plus I group. There is no plus I effect, there is no minus I effect in the last molecule because of different electronegative element is absent. But in the third molecule, the CH3 is connected with magnesium. This is the Grignard reagent as per the organic chemistry. So the Grignard reagent are MgX. This is magnesium. Magnesium is the metal. So these bonding electrons moving towards the carbon side. Carbon gets negative charge. So this is act as a minus I group. So Grignard reagent is in the Grignard reagent, carbon act as a minus I group simply. Here the next question is, how many resonance structures can be drawn for the following molecule? How many resonance structures? Resonance means moving of electrons, delocalization of electrons from one atom to another atom. Here the positive charge, pi bond, lone pair is there. So resonance structure, first resonance structure, the electrons are moving from here to here. After shifting, the resonance structure existing like this. Here the double bond formation, here the positive charge, here the lone pair is present. Another resonance structure, the lone pair of electrons moving from here to here like this. After shifting, the nitrogen loses lone pair of electron, nitrogen gets positive charge. This is one more resonance structure. Here in this resonance form, another way of representation, the pi bond lone pair of electrons moving like this. So after shifting, NiH2, here the positive charge, here the negative charge, here the pi bond formation. Look at here, number of resonance structures, 4 are possible. Resonance means delocalization of 5 electrons from one atom to another atom. Here the next question is, which of the following resonating structures contribute maximum to the resonance hybrid? Contribute means which of the following resonance structure is more stable structure, simply the question. Here the 4 resonance structures. In these 4 resonance structures, as per the resonance structures identification, rule number 1 is which is having more covalent bonds, more number of covalent bonds. That molecule is more stable, simply. Which is having the more number of covalent bonds, that molecule is more stable. In the 4 structures, the 4th molecule, observe the number of covalent bonds in that molecule. Here I am represented here number of covalent bonds. How many number of covalent bonds? Here in this molecule, 20 covalent bonds are present, but remaining molecules less than 20 covalent bonds are present. That's why it is the most stable. So rule number 1 in this observation. Next question, which of the following has maximum number of resonance structures? Maximum number of resonance structure depends upon the conjugation, simply depends on conjugation. In that 4 options, second option, observe that in the second molecule the positive charge is connected with a linear conjugation with all the pi bonds, not cross conjugation. Linear conjugation means the connectivities look like existing like this. Cross conjugation means the connectivity is existing like this. This is the cross conjugation type. This is linear conjugation type. This molecule, the pi bond electrons are connected with positive charge with linear conjugation simply. But remaining molecules, that conjugation is second molecule is the more stable molecule. Next question, observe that question number 33. Which of the following compound is not resonance stabilized? Which of the following compound? The option is actually third option. Why it is not resonance stabilized? Third option is bridged kind of molecule. Bridged molecule, that is bicyclic compound. Bicyclic compound means the molecule is existing like this. Here this carbon is called as bridge carbon. At a bridge carbon, charge is present, that molecules are unstable. Reason, the above molecule, the charge is present, here the negative charge, here the double bond Y is present. The bonding electrons moving like this carbon gets positive charge between positive and negative, double bond formation. Double bond formation like this, the molecule. But at bridgehead position, double bond is never existing because of hybridization is sp2. At a bridgehead carbon, the carbon hybridization always sp3 tetrahedral arrangement. Trigonal planar arrangement is not possible at a bridged carbon. Structure is not existing because of bond angle strain. The next question is stability order of the following resonating structures will be. Which of the following structure is more stable, which is least stable? That stability order is identifying based on these rules. What are the rules? Rule number 1, number of covalent bonds. In the molecule, which molecule having more number of covalent bonds, that is the more stable. That is the first rule. Rule number 2, neutral molecules are more stable. Neutral molecules are more stable than charged molecules. Next, rule number 3, negative charge is present on more electronegative element. That is the more stable molecule. Rule number 4, like charges nearer to each other unstable. Unlike charges far away nearer to each other more stable. So among the 4 molecules, by using following these rules, the order is, stability order is 1, next 2, then 3, then 4. 4 is next. Question number 35. Select the molecule in which pi bonds are conjugated. Conjugated system means what? Alternative double bonds. Alternative double bonds are present between the carbon atoms, that is conjugated system. This is not a conjugated system. This is not a conjugated system. This is conjugated system. Alternative double bonds are present. Double bond, single bond, double bond. Option is 3. Next, which of the following is not a valid resonance structure? Which of the following is not a valid resonance structure means option, look at the option 4. On the oxygen, double bond is there as well as -2 charge is there, 3 lone pair of electrons. This is not a valid resonance structure. Remaining are valid resonance structures. Question number 37. Resonance hybrid of this molecule. It is a conjugated system. Double bond, single bond, positive charge. The double bond is separated by with positive charge by one single bond. So that is the conjugated system. All carbon atoms having the positive charge. Option is first option. Next, compare relative stability of following resonance structures. These are the resonance structures. Relative stability they are asking. What is resonance structure stability identification? Observe the number of covalent bonds in every molecule. This is 8 covalent bonds, 8 covalent bonds, 7 covalent bonds. Both are equal number of covalent bonds. Which is the neutral molecule? This is neutral molecule, this is charged molecule. Neutral molecules are more stable compared to charged molecules. So stability order A, B, C. Follow the rules.